Okay, so this is how our end-to-end website looks. So the Covisualize website has three sections mainly. First, it has the real-time cases and deaths for coronavirus section where we'll be showcasing how the trend and the graph of COVID goes for a particular timeline and for different various countries. So in this dropdown, we have different countries. You can choose from it. We have different timelines. And let's say I want to see the graph of India with a time of 1 year. So this is how it goes. If I want to see it for 2 months, this is how it goes. For 6 months, yeah. So you get the idea, right? For Australia, similarly, over the horizon of 6 months, this is how it has been. For 1 year, this is how it has been, right? Yeah. So moving on to the next section, we have the predicted case and deaths for coronavirus, where we'll be predicting the cases and deaths of COVID over the future, depending upon the data that has been of the past 1 year, right? So let's say we choose India, and we can see this previous graph is of the real time cases, and this diminished colored graph is representing the predicted cases of cases. Similarly for deaths, right? You can remove the deaths one. So this is the predicted cases, right? You can remove the predicted cases to see it a little bit better. So you can play with it. For various countries, it goes like this. Similarly, for Canada, the graph will show the predicted cases and the predicted deaths. This uses the machine learning model for time series forecasting, basically, and it is called ARIMA model or SARI-MAX model to be specific, which takes into consideration the noise of the data, the trend, the seasonality of the data over the period, and it is the time dependent data that is then forecasted into the future. So that has been used. The next section comprises of sentimental analysis, which basically fetches the tweets of various people and searches for the word coronavirus in the tweet and performs an AWS comprehend, which is a technique, a model, library, whatever you can say, to perform sentimental analysis on a text. So that we have done, and this particular pie chart showcases the various emotions that people have had related to the word coronavirus. So it goes from negative to neutral to positive to mixed, right? So the graph, so the chart comprises of this particular sentiment analysis, right? This is the end-to-end product, and moving on to its code base. Here's the code base, and we have this client folder into which we have all the our front end part, and this consists of various components, right? So we have predicted.js component where we have used chart.js to render all the data that we have fetched from API and give it into a particular format in a graph, right? So it helps to make a beautiful graph out of it. Similarly, for realtime.js, the values of cases and deaths that we have of the past 1 year that we have showcased here in the front end. Similarly, for sentiment analysis, we have the components, and here we have made the pie chart, a beautiful pie chart to showcase all the emotions, right? So that all goes in the front end. For the backend, we have various files like the postman.ts fetches the data from the particular API and it gives it to this DynamoDB table and updates it into the DynamoDB table, right? And what happens from here is we have the data into the DynamoDB table and we can perform predictions and everything else. The Twitter file makes sure that we have the Twitter API working and it fetches the keywords and the tweets and then pushes them into the database again. So that goes on into the backend. Similarly, we have the lambdas, which are helpful to make the API endpoints of the particular cases that we have performed, the particular models that we have made. So this particular lambda makes an endpoint, and we can get the data from any table that we have in our DynamoDB. This particular endpoint we have for our sentiment analysis, which uses AWS Comprehend, and this we have used to get the data from DynamoDB and perform sentiment analysis on that, and then push it again in a new column, the sentiments of that particular text, right? These lambdas will be triggered whenever there will be a change in the DynamoDB table, right? Okay. Similarly, we have the SageMaker instance where we have all the code for the model, for the ARIMA model. I'll show it in the AWS console as well. Yeah, so this is my AWS console and I have my Lambda functions here. The co-op Lambda function is the one where we are getting all the data from the tables that we have made in the DynamoDB part, right? This one, okay? Similarly, we have the senti-lam table, lambda function, where we have all the data for all the code for this particular sentiment analysis. Okay, and here we have the DynamoDB, where we have different tables. We have four tables for cases, deaths, the final deaths, which consists of the forecasted values, the predicted values, and for the Twitter and for the final deaths. Everything is stored in the DynamoDB, right? In the SageMaker, we have this Jupyter notebook where we have written the code for forecasting, right? It makes sure that we get the data from DynamoDB and the data is used for prediction, and then the new predicted values are pushed again into the database. So this is all from our side. Um, that was the code base. This was the end-to-end project, and that's it. Thank you.